A cast iron separator plate fits between each clutch plate. This friction unit, that is clutch plate, is between the flywheel and the pressure plate when the pressure plate assembly is bolted to the flywheel. A pressure plate assembly consisting of a steel cover, a pressure plate and a segmented diaphragm spring and a release bearing and operating fork. The clamping force on the friction facings is provided by the diaphragm spring. When removed, diaphragm spring looks as dish-shaped. As the pressure plate covers tightens, diaphragm spring flattens out to exert a force on the pressure plate and the clutch plate. Now, as we can see, clutch plate is engaged with the flywheel and torque is transmitted from the flywheel through the friction facings, that is clutch plates, to the transmission input shaft, that is clutch shaft. Hence, rear wheel of the car also rotates. When the clutch pedal is pressed, the release bearing acts on the pressure plate diaphragm and moves the pressure plate away from the flywheel. This releases the clamping force on the facings and separator plate and allows flywheel to rotate freely without turning the clutch shaft. Now, the clutch plate disengages with the flywheel and drive is no longer transmitted. When the pedal is released, the spring tension forces the pressure plate, clutch plates and separator plates against the flywheel, clamping all components together.
while still retaining the ability to engage and disengage at speed and under load. These clutches can be used dry or in an oil bath. Running the clutches in an oil bath also greatly increases the heat dissipation capability. Typical applications are machine tool, industrial and marine gearboxes, automotive transfer cases, agricultural machinery. The key components in a multiple disc clutch are the bearing, coil, rotor, inner discs, separator springs, outer discs, armature, drive cup. Multiple disc clutches operate via electrical actuation but transmit torque mechanically. When voltage current is applied to the clutch coil, the coil becomes an electromagnet and produces lines of flux. Coil voltage is usually 24 or 90 DC, but other voltages are available. This flux is transferred through the small air gap between the field and the rotor. The rotor portion of the clutch becomes magnetized and sets up a magnetic loop which attracts both the friction discs and the armature. The attraction of the armature and discs squeezes the inner splined discs that ride on the rotor against the outer discs, transferring the torque. For an oil bath application, the oil is squeezed from between the friction discs, but a thin film still remains, so the torque is being transferred through an oil shear force. The tangs on the output discs push against a drive cup, which is attached to a pulley, coupling, or gear. Depending upon inertia and speed, the clutch will slip to accelerate the load, typically within 0.2 to 2 seconds. To disengage the clutch, current voltage is removed and the separator wave springs prevent the inner and outer discs from making contact. But there is still a minimal amount of drag present from the separator springs.
Several parts. It consists of a pressure plate held in place by using several springs and screws. This plate presses against the clutch pack. The clutch pack consists of several steel and friction plates placed in alternate positions. The clutch basket and the inner hub are assembled with their axes aligned to the input shaft of the gearbox. Now, let's understand the outer basket will be either impossible or too difficult. To eliminate this problem, the clutch pack is used in place of this hypothetical connector. Unlike our hypothetical connector, the clutch pack is a combination of separate circular plates. Let's take any two adjacent plates from the clutch pack. One of them is a friction plate, and the other is a steel plate. The friction plate has teeth on the outer circumference, which always interlocks with the clutch basket and can slide sideways along this clutch basket. The plate spins with the clutch basket, but doesn't affect the inner hub. The steel plate has teeth in its inner portion, which always interlocks with the grooves in the inner hub and can slide sideways along this hub. This plate spins with the inner hub, but doesn't affect the outer basket. As these plates can slide sideways, we can press them together, gradually increasing friction so that both of them start acting like a single unit, like our hypothetical connector. With this arrangement, if we spin the outer basket, the inner hub will also spin. This will eventually transfer power from the engine to the gearbox. Even if the plates are spinning at different RPM at first, the gradual increase in friction between them will eventually synchronize them. If we release the pressure, the two plates become independent. This will disconnect the inner hub with the clutch basket, and the engine power is disconnected. Several other plates are added to increase strength and surface area. Now let's understand how pressure on these plates are changed while riding a motorcycle. We use the pressure plate for this purpose. It has ducted attachments where a set of springs can fit in. A set of retainer bolts are screwed to the inner hub. This causes the spring to compress and apply force on the clutch pack, resulting in sufficient friction between the plates. We can release the pressure on the clutch pack by pushing the pressure plate outwards. We can control this pressure by pulling or releasing the clutch lever. As the clutch lever is pulled or released, a cable or hydraulic system rotates an actuator arm as shown in the animation. This arm presses against the push rod towards the clutch. This rod goes through a duct inside the input shaft and pushes the pressure plate, releasing the pressure on the clutch pack. When the clutch lever is released, the springs again apply pressure to the clutch pack, as shown in the animation.
Assume that you have a string tied to a stone. When you whirl the string, you can sense a force on the stone that tends to move it away from the center. This force exerted by the stone on the string is known as the centrifugal force. Centrifugal pumps, centrifugal governors, and some other devices use centrifugal force for their operation. We must know its construction. A simple centrifugal clutch consists of two members. One is a driving member connected to the shaft from the engine, and the other is the driven member connected with the shaft with transmission. The driven member looks like a drum and has friction lining on its inner surface. The driven member encloses the driving member. The driving member is provided with a spider and clutch shoes. The shoes have friction lining on their outer end and they are connected to the driving shaft with the springs at the inner end. The spider acts as the guideway for the shoes and the springs exerts radially inward forces on the shoes. Well, that's about the construction of the centrifugal clutch. Now, let's see how the system works. When the engine rotates, the shaft connected to the engine rotates the driving member. The driving member rotates with the spider and shoes as a single unit. Now, the mass of the shoes exert a centrifugal force and they tend to move away from the center, but the springs hold them in its position. As the speed of the engine increases, the centrifugal force increases and exceeds the spring force. Thus, the shoes move away from the center. When the predetermined engine speed is reached, the shoes press against the inner surface of the driven member. This makes the driven member rotate because of the friction between them. Thus, the clutch engages automatically at the predetermined speed. Next, when the engine speed decreases, the centrifugal force decreases as well. At this time, the springs tend to bring back the shoes to their initial position.